So, good morning. My name is Richard Pugh. I'm Chief Data Scientist at Mango Solutions, and I'm also the current President of the EARL Consortium, which was a good lively panel discussion on yesterday. And today I'm going to talk a little bit, as Matt said, about data scientists and data science teams. In particular, I'm going to talk about something called the Data Science Radar, which is something that we've been working on with our clients around data science teams. I'm going to talk a bit about the data science remit, some of the challenges, and at the end you'll realise a lot of this is an excuse for me to leave in flux about HTMLWidgets, essentially. So that's kind of what I'm going to end up at. So firstly, many thanks for being here at 9 o'clock for a talk on data science, because what the world needs right now is another talk on what is data science, right? I mean, there's not enough of those right now. But I hope you'll bear with me because we have, I guess, quite an interesting perspective given our history on what data science is and how it works. So for those who don't know, Mango is about 13 years old this year, and we're essentially a group of data scientists and software developers. And so we've been doing data science or applied advanced analytics for about 12, 13 years now. So we've kind of had to get people in the same room who were able to program and do the theory and present and create good graphics and do the technology all in one team. So I want to talk a little bit about a data scientist and who these wonderful creatures are, which you can all listen to. So if you look online and you look for what is a data scientist, you'll find some really good answers. I quite like this one. I think this one came from Josh Wills, I think. And there's slightly different wordings on this when you look online, but essentially a data scientist is a statistician who lives in San Francisco. That sounded quite right to me. You can always rely on big data for that, right? So data science is just starts with a Mac. You've got a really good quote from Corey. I love this. A data scientist is a device for turning good coffee into data for better decisions. I kind of like that one. And I think probably the most serious and probably most famous, perhaps, sort of in a nutshell tweet about data science is this, which is again from Josh Wills, and he said that a data scientist is a person who's better at stats than a software engineer, and is actually better a software engineer than a statistician. But you kind of get this idea whenever you look at data science of this kind of like meeting of skill sets that maybe weren't there before. Okay? And I think Drew took this, on switches. Really good. This idea, I suppose, of meeting skill sets is kind of where data science comes from. And you hear a lot about, as Josh said, that kind of development, if you like, writing code and stats. And Drew took this one step further, and this is probably the most famous diagram, I suppose, around data science right now. This is the one that was in David Smith's talk yesterday. I think it's been referenced a few times in this conference so far. This is Drew Conway, where he talked about data science being a mixture of sort of analytic knowledge, if you like, hacking skills, the ability to actually write code, and some experience, domain experience in particular. And it's the amalgamation of all of these that, in Drew's mind, kind of creates a data scientist. And I suppose what I'd start off with today really is talking about a little bit about the view from the Mango side. So we've been building a team for, like I say, about 13 years now. And within our data scientist team, we have about 17 people on that side of the organization. And over the years, we've had to hire people who have this kind of like amalgamation of skills. Essentially what we've been working on, and I kind of look back when I was doing this presentation, this work started in about 2006, I think, from what I can see from the notes, where we were talking about, in an interview, who we're trying to hire. And what we found that we were after really is a real combination of a number of different skill sets. For example, data wrangling. A data scientist, depending on which blog post you read, spends at least 127% of his time data wrangling, and the rest doing something else, right? So
there's a lot of that. But yeah, I mean, getting the data into a format that we can work with is a key skill. And that kind of increases, the complexity can increase with data size. When you're looking at things like a Hadoop stack, it increases with things like the different types of data we have to deal with, so the 3 Vs or the 4 Vs, or how many Vs we're on today, and again, which blog post you read. The variety of data in particular is increasing. Yeah. And also, I keep being kind of talked about, I keep going to meetings, people kind of go, oh, we're going to use Impala, okay, and then we're going to use Hive, and then you're going to use Drill, and then you're going to use, and there's all these new technologies, and I don't know, the big data world right now feels like, I don't know if they're running out Safari animals right now, but I mean, every time I go to a conference, there's a new, like I was at Strata a while ago, they were talking about Apache Kudu. Have you seen Apache Kudu? And I'm like, no, I'll be Googling tonight, so, so there's a lot of that sort of technology around getting the data in the first place. Programming is a key skill. When I became a statistician, and I'll talk about this later, I sat down day one in my new company, and I realized I had to become a programmer. And that was kind of an essential tool for actually doing my work, okay? But I never really had programmatic skill. So we've had to spend a lot of time at Mango getting people who are analysts, fundamentally, people who know the theory, and actually train them about how to be developers. And that will include things like exposing analysts to things like code patterns, unit testing, continuous integration frameworks, and so on. And that sort of stuff is the stuff that you kind of need to be a sort of industrial kind of data scientist, but that was perhaps not quite apparent. When I actually sit in an office where the other half of the office are software developers, they learn how to code when they're in university, so there was a bit of a mismatch there. Technology, I talked about the big data stack, and I talked about this idea that there's new technologies every day, and this is a real challenge right now to keep up with the market, especially when data scientists are very often the people who are supposed to be looking at innovation both from a theoretical and analytical, but also a technical perspective. And so being able to just use the cloud, being able to just use Hadoop, being able to just kind of like pick up Julia and do something. The whole thing about is R better than Python? Well, actually I think the answer more over right now is you need to be able to use both essentially. There's a lot of that pressure to be technologists fundamentally in the data science space. I think modeling is still key, so actually knowing the theory and the stats and so on is really important. I think that's still, when people talk about is a statistician a data scientist, I think fundamentally yes. And visualization as well, the ability to actually create a good graphic, explore data graphically and present a good story. But you can be brilliant in all of these, and I think the key one probably is the top one, which is communication. We can all be the best data scientists in the world if you take away the top button. We're never talking to anyone, we're never solving challenges, and we're never kind of like making change, essentially. So that's kind of where we've kind of looked at and been trying to hire over the years. And the way we kind of went about this is we built something called the Data Science Radar. And this has been kind of in incubation at Mango now for many years when I look back at the notes. But essentially all we do is we used to talk about the different types of skill set we need in the organization, and we used to turn that into personas. So we basically turned that into a set of personas that we were looking for in any interview situation. Okay? So basically then what we're able to do is, if I kind of show you my radar, is we're then able to sort of like, within an interview setting or within a training setting, is actually look at where someone's really strong and actually then reflect that in their career progression. And also when we're actually building teams, we can then take that into account. Okay? So let me just kind of show you a live version of what we've done with the Data Science Radar, if my shiny app is still going. Yes, it is good. Okay. So the way we do this internally, and the way we do this with external clients, is we build a lovely shiny app, shiny dashboard app. And what we basically do within our team is we have a number, I'll pick on Mark, we have a number of data scientists in our team. And basically what we do is we do a peer-reviewed scoring system internally at Mango to try and understand what type of persona each of our data scientists is. And this allows us to actually get away from the question of what is a data scientist and what isn't, and actually talk a lot more about what the key skill sets and what are the strongest traits we have within our team. And this has been really useful for us. So you can see this is Mark back there, who is one of our data scientists. Mark came from an IT background. So Mark is very much a technologist in the team. So when I want something to scale really quickly, when I want something to actually parallelize something really quick, Mark's the person I go to. If you contrast that with, I suppose one of our other key members of the team would perhaps be Hannah. So Hannah is a member of our data science team, but she came into this from a business analysis background. So she's one of the best people I've ever kind of come across for understanding conceptually what people are trying to achieve, communicating that properly, and actually then working between. If anyone saw my presentation yesterday about mortgage assets, Hannah was one of the people on the team who actually sat between the analysis and the business to understand and communicate that. Yeah. So, and if you look at something perhaps a bit more rounded, who else is in the room? Amy loves it when I talk about us, so we talk about Amy. So Amy's presented a few times already. This is Amy's profile. And what we do with this is, you know, at the moment we've been kind of using this as well, not just ourselves, but also with our customers. But what I've seen, which is really interesting, is the customers will look at this and go, you know, let's pick on someone. Let's pick on Ava. I say pick on. I mean, they all knew I was going to do this. Now, Ava is one of the people in the data science team at Mango. She's she's one of the best programmers I've ever come across. So as a trained statistician, she writes just beautifully crafted code. It's absolutely lovely. But one of the things with Ava that's quite interesting is she's quite shy. She doesn't really like going out and presenting. She doesn't like, you know, talking too much with, you know, and so actually that's kind of, if you look at the strongest trait, she's very much a programmer, but she kind of is quite shy naturally. Now, if you were to give this, and when we've kind of done this with customers, what they'll see is they'll go, aha, I spot a training gap. And what they'll then do is they then go away and they'll go, right, I'm going to take Ava and I'm going to send her on how we talk to customers and presentation soft skills course, right? And we kind of look at that and go, yeah, you know what, if I told Ava, good news, you're going to spend the next 6 months doing, you know, interacting with customers so you can increase that skill level, she'll leave, right? Because that's not what she wants to do, right? That's not exactly what but she's so essential to the team that I think what you have to look at here is not the gaps, but the strengths, and actually play to those strengths across the team. And that's kind of how we've used the radar more over at Mango. Okay. So yeah, so this is used by us, it's used by some of our customers. So as an example, we work with a retailer in the UK called Marks & Spencer, large retailer in the UK. They're building a data science team right now, a very large data science team. It's a really progressive initiative they've got going on. We're doing a lot of data science training with them, which will include everything on the radar essentially. So what is a good graph, what is good programming practice, and so on. But also we assess people against that radar at the start and at the end of the process. Okay, and kind of giving them an understanding of who they have in their team is helping them hire the next people. So this has been a really useful thing for us to do. So what I want to talk about now is unicorns. So we talked about these data scientists, and who do we want to hire? Well, we want to hire this person right here. There we go. Okay, there's a data scientist. Now, depending on which job spec you read at the moment with, you know, for data science, it's very often this is the person you need to be in order for you to apply for a job, right? Because you have to be an expert in. Here's 50 technologies that you've got to be expert in. You've got to be able to present. You've got to be a PhD level mathematician. You've got to be an expert in machine learning. You've got to be, you know, it's a crazy situation right now. But everyone's looking for these people. And I think one thing I can say is we interview about 4 people a week generally at Mango. We've been interviewing since 2002. The unicorns don't exist. My daughter's not in the room, she's like 7, she'd kill me for saying this, but unicorns do not exist fundamentally, right? And actually I think if you accept some of what I've said so far about the radar and the skill sets, maybe they're kind of like, maybe they're not supposed to exist. Someone who's brilliant in terms of like skirting over the detail and just understanding, well, what's important to you, very often isn't the same personality trait of someone who's really keen on understanding that complex error structure in that GLM that I just fit. Maybe these people are not supposed to be this, you know, have all those traits. And so we've seen that actually this quest for hiring, you know, people who are perfect in every axis is a real challenge right now. And in the early days of Mango, we had to have people who were very multi-skilled. But nowadays, what we do is we'll talk about, right, the next hire is going to be a modeler. So we'll go and get a modeler next. Or we'll go and get a visualizer next. And actually complementing the team, that kind of works really well. So what we do is we realize that we can't get the unicorn, but we can build a unicorn. And what I mean by that is I can actually hire data scientists with a number of these traits and actually put them together in a collaborative kind of team environment. And then what I have across the team is I have unicorns, but they're just made up of maybe 3 or 4 different people. Okay? And that's kind of how we go about team building. That's been a real shift for us from we need to go and find someone who is like an expert in these 6 things to actually let's go and find someone who's really strong in 1 or 2 of these traits and actually make sure they can integrate themselves into our team really neatly. Yeah? And that's kind of really cool. Let me show you an example of what that looks like. So if I go back to my nice shiny app. So this is the data science team at Mango. These are the data scientists that we have. And I picked on Ava earlier, so as a really good member of our team. And we noticed that the strongest trait here is programmer. Maybe the weakest trait is communicator. So what we could do is combine Ava with Hannah, and maybe we'll also put in maybe Lewis. And what we get overall with those 3 people is I've created essentially a full data science persona using 3 people. Okay. And then what I'm doing, instead of actually focusing on a single person to do all this, I'm actually focusing on allowing people to play to their strengths, maybe not do the things they're not so comfortable with or they're not so interested in, but actually overall still getting that full picture of a data science persona. And we actually use this tool internally for project work. So when there's a project that comes in, we'll talk about, well, what's the project? Oh, it's a graphical project. It's I want to create something graphical that we're going to implement some graphs and it's going to be some nice D3 stuff. And I'll go, right, okay, so let's build a team. We'll probably look for maybe 2 visualizers or 2 people who are really strong on the visualizer axis within that team to make sure that we've got the right mix of people. And that's kind of how we use this. Okay. Okay. So I've talked a lot about sort of skill sets of data scientists based on kind of where we've tried to hire over the years. But I thought I'd talk a little bit about something slightly different, which is the data science remit. So way back in 1998, a few things were going on. Google looked like this. This was the Google homepage. I think they came out around that sort of time. A group of American miners saved the world, thanks, which was a great film. There was some other stuff going on, like this guy was in charge, and I started my job. My first job at university was in 1998. And I arrived at my job and I sat down at my desk, and on the very first day there was a guy who'd been in the department as a statistician for 25 years, and he sat next to me and he said, "Congratulations on picking this career." And I said, "Oh, that's very good, because I'm kind of like out of university going to change the world, right?" So he said to me, "It's brilliant, it's a brilliant career. It's the safest job in the world." Now, I was a statistician in the pharmaceutical industry at the time. You could probably have argued that was pretty true, right? Yeah, safest job in the world, because, get this, no one knows what you do. Isn't that brilliant? And like, from kind of like this kind of coming out of the university, I'm going to change the world to no one knows what you do, was a bit of a bump down to earth, really, and that was a bit of a shock to me. But I think another thing that I noticed, that there were some real skills missing from my degree course at that time. Things like how to be a programmer, right? So I had to use SAS at the time, because that was the way they were doing things. I had to work out how to create a good graph. I had to work out how to communicate results. I had this really weird moment where the first bit of analysis I did in this company, I did this beautiful bit of analysis. I crafted it this beautifully. It was a very, very nice little model. And I presented my results, and my findings were, so yes, we should go ahead and do this thing. Blank faces all around the room. And I thought, oh, I've made some huge faux pas in this my early career's dead, what have I done? And afterwards I said to my boss, I said, I'm really confused, I can't work out what I did wrong there, because I took the data, I took the challenge, I did the analysis, I presented the analysis back, and I gave them a finding, and I said, this is the way we should go. Where did I go wrong? And my boss took me to one side and said, look, you didn't show a p-value. These guys are used to looking at p-values. So essentially, if I'd walked into the room and just gone 0.01 any questions, that would have been a better presentation, essentially. So it was kind of a weird environment, I suppose is what I'm getting at. And it was an environment where no one really understood what we did. And also, because there was a lack of understanding, people would just cling on to concepts they understand. They're used to looking at a straight line through a plot. They're used to understanding sort of maybe what a p-value is, because everyone understands what p-value is, right? And so those little bits, those touch points of knowledge across between the business and the analyst teams, were like the only thin little bridges between what we did and what the real world was actually doing. So it was a really strange environment. The other thing I noticed is I was very much I was a statistician, I was very much doing reactive analysis. So what do I mean by that? Well, we kind of sat in this room and people fed reports to us, please do X, and we'd write a nice document and we'd send it back. But it was reactive. There was no, I'll go out and like knock on the CFO's door and go, hey, what are you doing? Oh, Excel, can I help? There was none of that. It was like really kind of like, we knew our place, our remit was incredibly small, and we just reacted to reports. The other thing I noticed, and this was perhaps due because I was in the pharmaceutical industry at the time, is you got to remember, I come out of university and what I want to do is I want to come in and do something, and that like makes the company like millions of dollars, and I'm going to walk in my boss's office and go, I did that, let's talk about a pay rise, right? That was in my head, that's kind of sort of how it went, right? So I do something, I change the world a little bit, and then I go on to the next thing. But because I was in the pharmaceutical industry at the time, it kind of felt a bit like this, right? So I was doing analysis here, and then there was this big gap, and then someone made a decision, and there was this big gap, and there was a physical impact on the stock price. So I felt like, and all right, it was the pharma industry, right? So you've got like 15 years to make a drug. So I'm like, the idea you can tie something I did today to a shift in the stock price is really quite hard, right? And I sort of started talking to my people who I knew from university and said, well, how does this work with you? And people were like, well, in the marketing world, I'm a bit closer to things. It's kind of it's a bit nicer, and insurance industry is a bit more regulatory and so on. And I had some friends who did quant finance, and they went, oh yeah, it's like this. Oh yeah. No, I come in the morning, I make some sort of model, it gets implemented in the afternoon. We've made $1 million by the end of the day. It's great. I thought, well, that's really interesting. That's like, you've moved the analysis really close to the decision process. And I became fascinated with this idea of actually using analytics not in a sort of more reactive way, which is the way I was used to at the time, but a sort of more proactive thing. And I think a big part of data science to me right now is actually this shift from a reactive thing to a proactive. So that shift from, well, analytics is kind of like a research thing or a regulatory thing. It's kind of like a bywater, so it's not in the main flow of decision making. So if you're not in this week, that's all right. Pick it up next week, that's fine. If I don't get the report today, that's okay. I think data science has shifted us all far more into the line of fire, right? So now we're in a point where as soon as analytics is used to make decisions, you can't go, I'm not in today, because the decision needs to be made. All right, so I think the data science movement seems to have shifted us far more into that proactive style of analytics, which I really love. So for me, data science right now is two things. It's a team of multi-skilled people who are, across the team are unicorns, have these different skill sets that you can bring to bear. But it's also the remit within a company to actually go and make a difference. Okay, because I know a number of people, and I'm sure it's like you, but I know a number of people in London who have taken data science jobs on really good salaries, and then left after 6 months. And I go and talk to him, and I say, well, why did you leave? That seemed the perfect job. And he went, I didn't get what I did. No one knew what I do in that organization. I just went in, I was like this clever guy. No one knew how to plug me into anything. No one I worked with understood what I did, and therefore what I can help with, and therefore it just stops. And I think that's a real challenge right now, where people want to do things like data science, but maybe the companies don't quite know how to integrate it somehow. But I kind of thought went past this, and I thought, well, what if we get a wish? So what if you end up in an organization where two things happen? Number one, people get this mix of skills. People allow you to go and build a team of data scientists. You end up with a brilliant team around you. Okay? And what if, in that company, you're given the license to go and make change? You're actually given the license to go and proactively kind of get involved in decisions and actually start getting companies to make really data-driven decisions. So we get our wish. What happens then? Well, I thought I'd just quickly pick up on some of the things I've seen in the early days of this, where people have started to really put their faith in analytics. And I'll talk about 4 things really quickly. I could talk about this for hours, but essentially, I'm going to talk about a couple of things. Closing the business gap. I'm going to talk about defining success, which I think is really key for us right now. I'll talk about collaboration, and I'll talk a little bit about industrialization. Okay. So closing the business gap. So you're in an organization, you're a data scientist or a data scientist team, you do cool stuff, right? The capabilities that you have are fantastic across your team. Like within Mango, if anyone saw the mortgage pricing thing, the idea that we can do that in 6 days is just crazy. So that was a really good example of what data science can achieve. And then in your organization, you've got people making decisions. Day in, day out. Shall we do this? Shall I build another store over there? Shall I invest in this venture? Shall we buy this stock? Those decisions happen over and over and over again. And I suppose one of the biggest challenges is going to be this, the fact that right in the middle is this big gap between what we can do and the challenges that we can solve. So what we somehow need to do is actually make sure that we can bridge this gap and pull the two things together. So that means what we need to do is go and interact with business people in our organizations making decisions. So that's not waiting until there's a remit to do so. That is, and I found the best way to do this is over coffee, knocking on people's offices, whatever. What do you do? How do you make decisions? And and actually trying to help people. And also the other thing I've noticed is we need a language. So as a statistician, I think some of the terms that I hear, some of the terms I've learned about are, I'm not going to say they were engineered to make me sound clever, but they are really complicated, some of these things, right? I mean, you walk into an organization and you start talking statistically or mathematically or from a machine learning perspective, the people who are making decisions, they don't get that language, so we need a language. And I think that actually bridging that gap is going to be, the language is a big role to play. And we actually use the word model, essentially. That's kind of what we use. We try and use the word model from a mathematical sense and from a rule of thumb, everyday sense. And we try and use that to bridge the gap between business analytics. But I've also noticed that there are a lot of preconceptions. We have a lot of projects right now that are Hadoop projects. Now, as soon as someone mentions that they've got a Hadoop project, back of my mind, I'm going, run away. Because essentially, if you start talking to someone and they go, right, I've got this really good project, I want to use Hadoop to do, then you're already kind of constrained in terms of what you're actually going to achieve, right? So I think there's a real challenge right now around a sort of technology first, and okay, what are we trying to answer second, which is a real challenge. I think surely it should be what we're going to try and address, what challenge we're going to try and meet, and then what's the best technology to use. And also, there's a lot of, I read a blog post and stuff as well. I think that happens a lot, I suppose, with the buzz around analytics generally at the moment. And people kind of picking up concepts and saying, oh yeah, we should do it this way. And I suppose there's a lot of, and one of the things I suppose this comes down to also is I've been in situations where people will only turn to an analyst to solve a problem that they believe can be solved by analytics. So a really nice example that I'll use, that we haven't picked up on this conference at all. Has anyone ever drunk Tassimo coffee, Kenko coffee, Dow Egberts coffee, any of those sort of blends of coffee? Right, yeah? Great, brilliant. Okay, did you know that the coffee blend that you were using was written by R? So R drives the taste of that coffee. Okay? Which is weird, right? That makes no sense. How could that be? Well, what it took is it took an analyst in that company and a business user in that company to get together and go, oh, Mike, it's really difficult because when you make coffee, it's like raw ingredients and you have to put them together in the right way, but the consumer wants like a consistent taste. So how do I put the raw ingredients together in the same way to get a consistent taste every time? And an analyst went, hang on a second, that's an optimization problem. And that's kind of how that solution was born. But that's a really weird thing because usually what I see is like business people going, I want to know which customer to call first. Ooh, that's segmentation analysis. Let's go and do some classification. And then they go to an analyst because they believe that's a problem that analysts can solve. Okay? So I think we need to break down the barriers of what analysts can do and get through that. One of the tips, one of the ways that we've done this, which I really like, is we've been running some workshops at our customers where we force the business guys and the analysts in the room together, right? And then we form mini teams. We create theoretical businesses. So these are 4 of my characters from my theoretical analytics course. And what we do is we talk about each of these individuals. So this is Mr. Sunday. He runs an ice cream parlor. We talk about the sort of challenges that Mr. Sunday could have as a business and how analytics can help Mr. Sunday. Yeah, and we talk about how a model-based approach can help. And actually, when you get business guys and analysts talking together about, and starting to use words like predict and model in the same context, that's kind of, I think, what we need to do more and more, is bridge that gap. The only slight downside with this course is when you're in a room and people start talking about how Santa Claus is going to really increase his profit margin by, really, a little bit of you dies when you hear that. We're going to increase the proportion, artificially increase the proportion of naughty children just so that we can reduce our overheads. So that's kind of one of the things that we need to do, is to really close that communication gap between business and chat and the analytics, so we can actually solve some challenges that have got dollar values represented in them, yeah? And actually that comes into the second thing, which I think is going to be a real key challenge moving forward, which is, what does success look like? If you accept that analytics is a learn and confirm process, we're going to learn something, how do you get someone to invest a load of money in a data science team on the basis that we hopefully will learn something? That's a real challenge. And we find this all the time in terms of, like, if we're going to do, like, we've worked with a lot of sports teams, right? And the sports teams have got vast amounts of data. And it's one of those kind of projects very often where people come to us and go, we've got lots of data, tell us something. And again, alarm bells will ring a little, I think, as data scientists there, because tell us something is a very difficult thing to define. And I think actually carving out what success looks like at that moment and all along that chain is really important. So I think within an organization, when you're making investments in data science, we need to be really careful of the Big Bang approach. And let me give you an example of that I'll anonymize. I know a guy in a company who decided that data science was, like, going to solve all their problems. Data science was the way to go. We're going to become a data-driven company. And I applaud that, brilliant. That's exactly right. But the way he went about it next was interesting. What he did is he went board level, and he went, we're going to become a data-driven business. You need to give me $9 million, right, to the board. And the board went, yeah, why not? There we go, have some money, right? And this guy built a team, and the team of data scientists essentially grew from about 8 to 85 within a year. Now, anyone who's trying to hire data scientists right now knows that's a hard thing to do, right? So how did he do it? He went and bought people out of hedge funds. He got 2 people from NASA. He got 3 people from the Met Office. He went to investment banks and said, I'll pay you more, right? So he built this team, this amazing team. I've never seen anything like it. But also at the same time, he built it, and the way he was able to build it, because he had significant investment at board level in the company. So what happened? Fast forward 6 months, the people in this data science team got a sort of very informal new nickname internally at this company. Internally, these people in this team were called model-gicians, which is a sort of amalgamation of modelers and magicians, essentially. What I mean by that is, because they borrowed so heavily to build the team, the expectations on the challenges and the money this team was going to save were through the roof. So essentially, these people were basically like, any challenge in the organization, you'd bring in one of these guys from this data science team, and the guys were supposed to come in, these model-gicians, and wave some sort of geeky math wand, and like all the problems would go away. And the expectations were set so high, they could never deliver on the investment that was input in the start. And the team went from like 8 people to 85 in a year, and then 85 to 20 in a year, essentially. And because, I think what we have to be careful about is actually understanding at each point what success looks like. And I think incremental changes and sort of small wins is the key to that. Collaboration is another challenge I think we're going to face. If you accept that these people are going to work in teams, and you accept that we're in the firing line and we're doing proactive analytics, we can't take a day off, then actually we need to actually be able to do analytics in a truly collaborative manner. Now, it's not just GitHub, that's not just continuous integration. Now, those are key parts of it, certainly. But if you also accept that some of these people are not technical, or maybe they're really major in theory, stats, machine learning, but they might not be programmers, they may not understand what the cloud is, they may not understand really technical elements, then all of a sudden things like, oh, we'll just use GitHub and we'll just use continuous integration, we'll use this, all of a sudden you have to think about not just the technical stuff, the DevOpsy stuff, but also, well, how are we going to learn as a team? Because if analytics is all about understanding and learning, then actually that needs to also be part of our collaboration, not just the technical stuff. So if I learn something about a model or learn something about a variable, how do we do that? And we've had conversations at Mango with customers right now about evidence boards in police stations. Now, whenever you see a film, you'll get this shot in the background, they're all standing on this board, and there's like photos of someone pinned here, there's a line from there to there. And that's a police team working as a team learning something about a case. And that feels a bit like us. That feels a bit like data scientists, if you're in a team and you do an analysis, actually you need to understand as a team what makes this data tick, what are the patterns, and actually understanding those kind of like soft metadata-y things that is going to be really key going forward, and how you track that. One last one then, industrialization of analytics, I won't talk about too much. But if we are going to plug ourselves into the mainframe and actually solve some business challenges, then actually the code we write needs to be industrialized from the start almost. We need to be writing our code, writing our the structures that we have from the start to be scalable and injectable into a business process. And we've seen some really good examples of that, like David was talking about the Azure ML stuff yesterday. We saw how you could actually create web APIs from that and so on. We've seen lots of good Shiny talks, including mine sort of a Shiny talk in disguise, right? And stuff. So you kind of see that that's become really important as well going forward. So I won't say too much more apart from I'll just got a quick note of some of the tech I've done here. So I built this Shiny app, this data science radar thing. I originally did it using base graphics. It looked a bit like this. So basically I had a Shiny app and it called R and it used base graphics and it was okay. Then I came across this. It's a lovely JavaScript library called Chart.js. Okay? And what I did is I kind of thought, oh, if only I could use this nice interactive radar charts thing that's from Chart.js. So what did I do? I looked at something called HTMLWidgets. Now, who's used HTMLWidgets here? If you haven't, you've got to look at this thing. It's just awesome. Basically, what HTMLWidgets allows you to do is it allows you to take essentially a JavaScript visualization library and take R and stick the two things together so I can actually write an R function that creates a JavaScript visualization. So what I now do is when people tweet me some sort of cool interactive visualization thing, the first thing I'm looking at is, right, where did the JavaScript come from and can I actually drive it from R? Okay, so that's kind of what I've done. All those little JavaScript-y kind of radar things on the screen when I was doing that earlier, those are all driven from R stubs essentially. And a big up to, I don't know if anyone's in the room on this list, but a lot of the guys who've done this, there's some really cool kit there, and I really kind of suggest going to look at it. In particular, there's a website called Bower.io, which is like a collection of lots of different JavaScript visualization libraries, and there's actually a function in HTMLWidgets called scaffold widget that gets you like 80% of the way there. So you just basically say, I want that Bower.io visualization. I use this scaffold widget function, and it creates like a structure that actually allows you to then actually build R functions that call these JavaScript things. And then of course you can plug them into the Shiny dashboard. So that's kind of what my app did look like at the end. Radar chart is a little R library that calls Chart.js to draw those visualizations. The whole thing is a Shiny dashboard, and I use a little library called ShinyBS to add some of the buttons. Okay, next step, just to kind of point out, the radar chart stuff and soon the Shiny app code that I've shown you is all going to be on our GitHub page. The radar chart one is there now, so you can go and have a look at that, but the Shiny code is going to be there soon. And also, I just want to point out, we've been asked a few times about this radar thing in the UK. So what we've just done, this is a bit in stealth right now, but on the mangosolutions.com/radar page, what we started to do is build up the ability to actually go through and actually play and define a radar for yourself or your staff or your team as a way of playing. And currently it looks like that. So there's actually, at the moment, we're going to start hosting this thing and allowing people to use it. What do you want to use it for? I don't know. When we talk with Marks and Spencer right now, they get their employees to go and actually fill this in. It becomes part of their internal profile. We use it as a profiling tool. We've got people who use it as a nice, hey, cool, look, I'm a visualizer kind of tool. So I don't quite know how you want to use it, but we're going to host that as well. So that's coming along properly soon. Okay, so just a very quick thanks at the end. Thank you to our studio for Shiny. You can all say that. Thank you for the HTMLWidgets library, which really helped. Thank you to Doug, wherever Doug is, and there he is, and Shane for helping me do the HTMLWidgets stuff. Very handy when you can just turn around to the next person in the office and they know JavaScript back to front. Stops you having to hack that, which is kind of cool. And just last kind of thing, what is data science was kind of the theme for this talk. It's an opportunity, essentially. And I think that we're at a really good time and place to actually really nail this opportunity if we can get us positioned and solve some really big challenges. And so, yeah, I'll stop talking now. Okay, thank you. So it looks like I've got time for a couple of questions. Yeah?
I'm just curious to know if you ever reassess your employees to give them a new rating on each of those 6 scales, or if you just set once they satisfy?
Yeah, so the question was, do we reassess? We do actually. It's part of the appraisal process at Mango now. So basically what we do is we look at the radar. So let's use my radar. So we look at the radar, and then we do 2 things. This thing here is an amalgamation of the scores from my peers, essentially. So this is a team score that I use. But what I also do at the same time is we fill in self-assessments as well. So that was a really useful exercise at the start for where we think we are versus how we're perceived. And what we found, I suppose, is that people, you kind of go, I'm not such a good programmer, but actually then your peers will go, actually a really good programmer. So that was kind of useful. And then what we do from every appraisal is we actually then look at this, and we reassess, and then we talk about training and where people want to go and stuff like that. But I think the focus that we've shifted away from is not, oh, you've got a low score here, so let's fill a blank, to, oh, we've got a high score here, let's get you even further along that pillar. And that's a much more positive way, I think, of working, and I think it helps people to focus on the things they're good at. And when you actually put them in the team, that's great, right? You haven't got gaps. Yeah? Yeah, that's hard. That's the hardest one. So we have ongoing, I'll say discussions, about how you score yourself on each of these axes. And some are really easy, right? So programmer, right? If you're a programmer, then you can talk about, maybe how do you write code? Are you a hacker more than a programmer? On this you can see I'm like a 3 out of 5 as a programmer, which is obviously wrong, right? That's easy. Communicate is really hard. That's really, really hard. So the things that we do, let's give an example. When we're interviewing, one of the key questions in the interview at Mango, probably the killer question, is I say to someone, talk to me about some analytics that you've done recently. And people will start going, oh yeah, I did this really cool Bayesian hierarchical model thing. Oh, great, let's talk about that. And pretty soon we've got a board full of Greek letters, and it's, oh, that's kind of how we do it. And I go, this is wonderful, I love this. Explain this to me as if you're talking to my mum. And that's the moment where the CEO goes, I don't get it, and you have to explain it. That's a key moment, and where I think data science can live or die. And that's a key skill that we try and test for internally at Mango. But it's experience. A lot of it is experience of presenting, of actually having exposure to being in client meetings, of understanding what requirements look for. We actually talk about how do you gather requirements from a customer till you understand what the aims are, what constraints are, and then we talk also about that flip of, okay, well, you did this really complex project like the coffee thing, right? That was a heavy optimization problem. How would you then turn that into something that's a bit more simplistic and stuff like that? So that's actually the one that's the hardest to quantify, because a lot of it is subjective and experience-led, I think. The others tend to be easier, actually. The others tend to be things like, how much SQL have you done? What's your favorite language? Why is your favorite language? What makes good code? What does your structure look like? What is unit testing? What's the latest blog post you read? What was that about? What Apache thing did you? What do you want to learn next? What technology and why? And you want to see if someone's fundamentally curious about innovation and technology and so on. But yeah, the communication is the hardest one. One more? No? And Garrett's got a couple minutes. Oh, yes?
So this looks like a generally useful tool for other types of business companies. So do you have any plans to help others, not only people that want to read data scientists, to actually use this kind of tool to help them build the teams? Because I think generally it's pretty an idea.
Yeah, I think so. I think that I think this in itself, we're really proud of, and we've seen that people are using it in a number of different ways. We've got one customer who just used it to explain to their bosses what data science is, essentially, and why they want to hire this person and that person. We also use it to identify like gaps in teams, and so I had a customer recently who we interviewed all of their data scientists. We won this data science training program, and I came back and said, you need to hire a modeler. And they're going, yeah, but I want to hire a modeler who's brilliant at presenting and this. And I went, no, forget all that. Hire someone who is just nailed on like the stats and the modeling, because you have that. Hopefully you may be this person, but I've got that person in the office, and I turn to them all the time. Yeah. But the other thing to note is that we've done this for data science, but actually the technology that we're using here, you can define other axes, right? So what's important in your organization, and you can measure it like that. So, okay, no problem at all. Thank you.